Okay, guys, today what we're going to do is we're going to look at box plots. So this is another version of displaying our data. The big one on this, we're going to start again with a few of the definitions. You'll see there's a lot of vocabulary today. Box plots are very vocabulary intensive, but once you get them, these are actually an extremely easy one to do. Why? Because literally all we're doing is finding three medians. Okay? So medians are easy to find. All we need to do is line our data up in order from smallest to largest and figure out, do I have an even or odd data set? Remember, if I have an even data set, I'm looking for the two numbers in the middle. I add them together and divide by 2. If it's an odd data set, I'm only going to have one number left in the middle. When we are doing this, when we look at the measures of spread, what we're talking about is it's a measure that is used to describe the distribution of the data. So how far spread out it is. There's my pen. Quartiles. These are the values that divide the data set into, I'm going to add spread up here on this one too. So just looking at the word quartiles, how many parts do you think it's going to be divided into? 4. So it's going to be divided into 4 equal parts. So the first quartile, when we're talking about it or writing it, all we're going to do is put Q1. That means first quartile is the lower quartile. To be able to find, Connor, to be able to find the Q1 value, all we need to do is find the median of the lower half of the data. So basically, I'm going to find the median of my data set, and I'm going to use that midpoint and find the median from the bottom to that median. So like I said, we're just finding a second median inside of there. So the third quartile, anybody want to guess how we represent that? Okay. Q3 is the upper quartile. For this one, again, we're finding the median, but now we're going to be looking at the upper half of the data set. So once we've divided it in half by finding the median, I find the median of the lower half for Q1. I find the median of the upper half for Q3. Once I have found those two quartiles, Q1 and Q3, then our quartile range is the difference between Q1 and Q3. Or in other words, all I need to do to find the interquartile range, which we call the IQR, equals the Q3 value minus the Q1 value. Very simple to do. Range, we've already had that one before. So range is the difference. And here's where I'm going to throw a couple of new terms on you. So normally we talk about the range being the, Owen? Higher than the lower, right? So higher or highest and lowest data values. But when we start talking about box plots, we're going to add a couple of terms to it. One that we're going to call the highest is going to be the upper extreme. The lowest is going to be known as the lower extreme. Another way to think about it, the highest is your maximum value, which we'll just abbreviate as max. The lowest is going to be your minimum value. We'll just call that the min. Make sense? Everybody tracking so far? Good. Now here's where it gets a little more complex. Finding our outlier. When we did dot plots, we talked a little bit about outliers, and we just told you it was basically just a generic eye test. Do I have one point that is way separated from all the rest? It had to be one single point, and I told you at that point, later on we'll get you a better mathematical definition. Here's your mathematical definition. So what we do to find an outlier is a data value that is either much greater or much less than the median. We call this one an outsider because it is outside of the interquartile range being multiplied by more than 1.5 times. So the interquartile range is going to help give me my definition for an outlier. Because the closer the box is, the closer my interquartile range, the more concentrated the data. So an outlier is not that far away. If my data is really spread out, you have to be way outside to get an outlier. So when a data value is more than 1.5 times the value of the IQR beyond the quartiles, that is what we call an outlier. So how do I find it? Let me show you how to find an outlier. Add this onto your notes right below here. To find the outlier, what do I need to do? I take my interquartile range, and I'm going to multiply by 1.5. That's going to give me some value we'll call V. Okay? I then take that value V, and I subtract it from Q1, and that gives me my number K that tells me if it's an outlier. Lower than K is an outlier. We'll have some examples to put numbers to this later. The other one that I'm going to do, because I got to check on both sides, I'm going to take my third quartile times V plus V, and that gives me that second number K, not upper, higher than that value of K is an outlier. So again, I can have outliers on both the upper and lower sides of my data set. So now that you've got that little formula, the next thing I need you to do is just draw a nice straight line. Hopefully straighter than mine. You guys get to use a ruler. I can't. On my straight line, I'm going to put 5 points that are equidistant. So I'm going to have one at the very beginning, one at the very end. I'm going to have one right in the middle. Then I'm going to have one in between the first one and that middle one between that middle one and the last one. These are the 5 points that you need to draw a box plot. The first point is going to be our lower extreme, the first data piece of data in my data set. The second dot is going to be my Q1, my first quartile. The middle dot is going to be the median of my data set. The third dot is going to be my Q3. And the last one is going to be my upper extreme. You already have that written out, Owen? Good. Now, I want you real quick, just draw some lines kind of like this. Here is where box plots get their value. In a box plot, it's very easy to take a very large amount of data and be able to break it down so you can understand trends. Box plots are normally used at a really big level if I have a whole lot of information, because the one downside is I can't find individual data in a dot plot, or in a box plot, sorry. So what I'm looking at is just percentages. So if I'm looking at quartiles, what percent of the data do you think lies between the lower extreme and quarter one? 20? Why'd you say that one? Because I put 5 dots, right? But look at the lines. How many spaces do I have? Good. So that makes logical sense, right? So that would be 25% of the data, wouldn't it? So how much of the data do you think lies between Q1 and the median? 25%. What about between the median and Q3? 25%. And between Q3 and the upper extreme? 25%. So while it doesn't give me individual data, the nice thing about a box plot is I can really see which part of the data set is it in. Is it in the lower side or is it the upper side? This is really big in academics because we're trying to make sure you guys understand the standards. So we want to see everybody as much as possible push towards that upper extreme. that you guys actually understand what you're doing. And so our testing results help show this. Now, to put a visualization to a couple of these other terms that we just gave you, if I draw a little box here between the Q1 and Q3, anybody, can you, looking at your definition, can you figure out what that is? Awesome, well done. That's my interquartile range. It covers that distance from Q1 to Q3. So how much of my data is located in the interquartile range? Did you not get a sheet, Seth? You shouldn't wait this long to tell me. My apologies. So you got a lot of catching up to do. We're on the bottom of the first page. Now the other one, the other definition we gave you up there was, did we answer that question? Or did I get distracted? How much of the data is in the interquartile range? 50%. The other one that we gave you is the actual range. So the range, the IQR I find by taking Q3 minus Q1. My range I find by taking the upper extreme, subtracting the lower extreme. Any questions on this page? Okay, so we were setting the background for what we're going to be doing today. The next page is going to give us just a few more definitions. So today what we're looking at is box plots. So a box plot, also known as a box and whisker plot, which is how I've always called these before, uses a number line to show the distribution of a set of data. By using the median, the quartiles, and extreme values. A box, hence the box part of the box plot, is drawn around the quartile values, so the Q1 to Q3, and the whiskers, which is why we used to call it a box and whisker plot, extend from each quartile to the extreme data points that are not outliers. And that is a key piece here, guys. If they're not outliers, then they're included in the whiskers. Excuse me. The median, Q1 and Q3 are all marked with a vertical line. That is part of what makes the box plot. So what are we talking about? Again, we have 5 points that we're going to actually plot down. We're going to plot the lower extreme. Notice you have a number line, right? It's got to be a number line, and your number line has to include all of your data points. On that number line, I'm going to plot my lower extreme, my first quartile, my median, my third quartile, and the upper extreme. So you're going to see all 5 of those dots every single time. If you do the test and you have an outlier, outliers are normally annotated by the asterisk. So that shows us there was this data point that's way out here that is an outlier to our whole data set. Once I have plotted all 5 of those points, the very first thing I do is draw my 3 vertical lines. I draw a vertical line at Q1, at the median, and at Q3. Make them all exactly the same length and make sure that they're all vertical at that number point. Then I'm going to connect all 3 of those and make that my box. Once I've done that, I'm now going to go from the plot at the lower extreme, connect it to the dot at the middle of my box on the left, and where I plotted my Q1, and then I'm going to take a line from the Q3 and extend it to the upper extreme. That's not a good thing. Okay, so box plots separate data into, how many parts did we just show you? 4. What is key about those 4 parts? They are all equal. So it separates the data into 4 equal parts. Even though the parts may differ in length, and that's a key concept, each one of them contains 25% of the data. The box shows, what percent did we say? 50, because that's my interquartile range, right? So 50% of the data is right inside of the box. A common misconception is that the median always divides the box in half. That is not the case. I'm going to make that middle mark wherever my median is. It is possible that my box might look like this. Could also look something like this. Every once in a while, you'll get lucky, and that line actually does end up right in the middle, but that's actually more the exception than the rule. So realize that middle line doesn't always go in the middle of the box. It goes wherever my median is. Does that make sense? Okay, good. Hope it'll make more sense too as we work through a couple examples. So first off, and I forgot to ask this, who's got the dot plot data where we took all the measurements for heights? Do you have that handy? Can you pull it out real quick? Awesome. Man, you had it right up front. Okay, so this isn't the raw data though. This is the histogram. Do you have the dot plot one? Okay, so I'm gonna give you guys a heads up. I'm just gonna give it to you in order. So I just need you guys to write this down as I give it to you. So this is the B2 class. So our data looks like this. Step one, we need to order the values from least to greatest. If they give me a random table, I just have to reorganize it. I'm reading it straight off a dot plot. So one advantage of the dot plot is it's already been put into order. So our first number was 54. Then we had two 59s. We had three 60s. We had 161. We had four 62s. We had two 63s. We had a 64, a 65, a 266, a 67, and two 68s. What do I always do once I've reordered my data? Count. Cannon, you should have known it's to count, not shrug your shoulders. So we count. I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 19 pieces of data. Does everybody match that? Double count. Make sure you got 19. If you don't have 19, look at the list that I gave you. Figure out what you missed. Good. So now that we've done that, I need to draw a number line that covers the range of the data. In this case, I've already done that for you. It's already on your paper. So we've done that part. Step 3, now is where we're going to start breaking the medians. And this, guys, is what makes this very easy for us. To find the medians, what do I need to do? What is the median? What's the definition? The silence is disturbing me. Come on, Mackenzie, you know. How do I find the median? Owen? I have 19 numbers, so where's my median? Jake? Which would be? Okay. It's an odd number of data, right? So that means I'm going to have one number in the middle. So it's not going to be 9.5. It'll be the 10th. It's going to be the 10th value. Because if I do the 10th value, I've got 9 before it and 9 after it, right? So I just look, now that and here's why it's so important, guys, that my list is in order. So now I find my 10th value from lowest to greatest. So 2, 4, 6, 8, 10. It's that 62. So there's my median. So my median was 62. Now, what I'm going to do is bracket from that point. I'm going to go higher and lower for my first quartile and my third quartile. So I'm now going to, because this was an odd data set, the 62 is going to be my break point for both of those. So how many numbers did I say I have on the lower half? 9. So if I have 9, where's my middle going to be? If I have 9 numbers, how is 10 going to be the middle? The 5th one. 4.5, half of 9 is 4.5. I need the middle. It's going to be one number because it's odd. That makes it the fifth one. So my fifth data, 2, 4, 5, is 60. There's my Q1. So high is that my Q1? Because I have 4 before it, 4 after it. That's the median of the lower half. Now, does that make sense to you? Now I also have to find the median of the upper half. How many numbers do I have on the upper half? 9. So it's the middle. Still the fifth one. So now on the upper half, I count 2, 4, 5. There's the middle one. I have 4 before it, 4 after it. That is my Q3. So my Q1 value was 60. My Q3 value was 65. My upper extreme, what was the largest number in my data set? 68. My lower extreme, what was the lowest number in my data set? 54. My interquartile range. Again, how do I find interquartile range? It's just Q3 minus Q1. So it's 5 in this case. Now, let's do our outlier check. How do I check my outlier? I'm going to take my IQR 5 times 1.5. So, you guys want an easy way to do this? What's half of 5? I just added to that. 5 plus 2.5 gives me 7.5. So what I'm doing with that value now is I subtract that value from my Q1. So Q1 minus 7.5. My Q1 in this case is 60. It's going to get me 52.5. Do I have any numbers below 52.5? No, so I don't have any outliers on the bottom side. Now I take my Q3 and I add the same number, that 7.5. My Q3 was 65 plus 7.5 gives me 72.5. Do I have any big numbers bigger than 72.5? That means my data set has no outliers. Is that an easy check? Do you understand now mathematically how to get the outliers? Okay, we'll get a couple more examples, but this is just giving you the quick check. Now, to actually make my box and whisker plot, it's really simple. All I need to do now is mark all of these with a dot above the number line. So 60, my lower extreme is 54. I put a dot. Make sure you draw your dot high enough that you can have room to extend a box underneath it without getting to the number line. Okay? Then I'm going to draw, my next one is going to be my Q1. That's at 60. So these dots need to, pretend that if you were doing a dot to dot with them, you would draw a line parallel to your number line. So they're all that exact same height above your number line. Next is my median. My median's at 62. The third number is my third quartile, which is at 65. And the last number is my upper extreme, which was 68. From here, the next step is really easy. My middle three boxes, I draw a vertical line that is the same height. Make sure you can still see your dots in the middles. And then I'm going to connect the top and bottom of those lines. Again, I wish I had a ruler. It would look a lot nicer. Those of you that are able to use rulers really should. And the last step in drawing my box and whisker plot is basically a dot to dot. I connect the first dot to the dot for the first quartile. I connect the Q3 dot to the upper extreme. Do make sure that all 5 of your dots are visible so that you can tell where those dots are located. And that is a box and whisker plot. Pretty simple, right? Yes. Basically the format. Mathematicians have come up with this as a way to visually recognize that this is a dot plot. If I just had 5 dots up there, it would just look like I had 5 data points. But because of the format, when I look at this visually, I now know, oh, 25% of my data is here, 50% is in that middle, 25% is at the end. Okay, it doesn't, not, again, one of the downsides to a box and whisker plot, it doesn't give me any individual data. all I can really tell is I had one person who was 54, at least one person, I think it could have been more. I had at least one person that was 68. All the rest of them are just medians, so they may not even be in my data set. But I do know that the median of the data set was 62. And I do know that 25% of the data points went up to 60. The next 25% showed up between 60 and 62. The next 20%, 62 to 65. And then 65 to 68 was the last 25%. Okay? Questions on drawing it? Okay, let's go ahead and turn to the next page. Talk a little bit more about interpreting it. I'm going to give you guys 8 minutes. I want you to get some practice. We've written the steps out for you in order once again. So just follow the steps and try to get this done. I do want you to try to work on this by yourself instead of the table, because I need to be able to see who is struggling on this one. Okay, so I'm just working the problems while the kids are finishing up their stuff. I've already ordered the numbers. There's 27 in my data set, so the check means that I check to make sure what the numbers were. Finding my values, since there was 27 values, number 14 was my median, which is at 85. So my first quartile, I'm now looking at that lower half of the data set. I have 13 numbers there, meaning it's going to be number 7. So I go 2, 4, 6, 7 is the 78. And I'm also going to find the 7th in the upper half. So, and I did forget the 87. That's how you see that one up there. So 2, 4, 6, 7. It's going to be the 94. My air quartile range, I'm just subtracting those two numbers. Gets me 16. And then I put those numbers onto the line. So my lower extreme was a 52. Actually, I need to do my data check first. So 16 gets me a 24. 52 was my lower extreme. 78 minus 24 gets me a 54. So 52 is actually an outlier. Okay, since most of you at least have some of this, let's go ahead and walk through it real quick. I ordered up my data. You'll see the 87 up here. I actually missed that initially, so I had to put it back in. But when I counted, I saw I had 27 pieces of data. So there's my check. 27. I divide that by 2 is 13 and a half, meaning that my midpoint is going to be at 14. I know I'm going to have one individual data point because it's an odd data set. So I counted in the 14th data point was the 85. Okay? So since that was 14, that means I have 13 on the lower side, 13 pieces of data, meaning my middle on that is going to be the 7th one. So I counted to 7, that was 78. And then I counted 7 past my median, got me to the 94. So that was my Q1 and my Q3. So I put those in. I have the median was 85. The upper extreme was the 100. The lower extreme was the 52. My first quartile is that first one at 78. Third quartile is that last one at 94. Gave me an interquartile range of 16. Doing my outlier check. 16. What's half of 16? 8. That means I'm looking for a number that's 24 away from my Q1 or my Q3. So I subtract the 24 from 78. That gave me 54. Do I have a number lower than 54 in my data set? Yes. 52. That means 52 is an outlier. Okay? Then I take the 24 and I add it to 94. That gives me 118. Do I have a number bigger than 118? No, so I don't have any outliers on the upper side of my data set. So because I have an outlier of 52, at 52, that's supposed to be an asterisk. Didn't show up as good. So the first thing I put on there is the asterisk at my lower extreme. That shows that that number is actually an outlier. Because that's an outlier, I now go to my next data point, which is 68. Okay, so now we've determined that our next data point in our data set is the 68. So that's where we're going to mark our lower extreme now, since the 52 was an outlier. So the first dot I'm going to have on my graph is at 68. The next dot is going to be at my first quartile, or 78. So that's going to be just before the 80. My next one's going to be the median, 85. Next one will be at the third quartile, or 94. The last one is at the upper extreme, 100. Again, the middle three dots now get a straight line, all equidistant, and I connect those with a box. My whiskers go, because the lower extreme was a outlier, I now go to that next data point to connect my line, then from the Q3 to my upper extreme. Again, do make sure that your dots are visible within those lines so anyone looking at your graph can tell where they're at. Bam, I'm done. That's all you got to do. You're finding three medians, plotting those points. Welcome back. Questions on doing that? Does it seem fairly easy? Why not, Cannon? It's just the median of the upper and lower halves. Once I have found my median was 85. Because I had one number in the middle, I just ignore it now. That's my dividing point. So what's the middle of that half of the data? I'm just finding the median again. 78. What's the median of this half of the data? 94. It's literally all I'm doing. Finding the middle number. Because 52 is an outlier. So if the ends as an outlier, my whisker goes to the next data point. I did tell you. You can play back the video yourself and you'll hear it. Any other questions? Okay. That's it for that page, guys. Let's turn the page again. So now that we have drawn the box plots, let's talk about interpreting what they say. So we know how to make it, but now do we know what it means? Does a box plot show individual data? No, it doesn't. It shows two pieces of individual data. I know at least one person scored a 68. I know at least one person scored a 100, but I really don't know any individual data. So if I don't get individual data from a box plot, what does it show? Spread, the distribution, right? So it shows the spread or distribution of the data. I can see how far it's spread out. So if the length of a whisker or box is short, what do you think that tells you about the values of the data in that part? Good. So that means they're really, the math term we would use would be concentrated. So it means the data is concentrated in that area. In other words, I see a lot of it right in that small piece of the area. Okay? So then what does it tell me if they're long? If I see a really long whisker, a really long box. The opposite, which what would be the opposite, the mathematical term opposite of concentrated? No, it's actually dispersed. So the data is dispersed. In other words, it's spread out. Or in Cannon's terms, the opposite of concentrated. So let's look at an actual visual and see what we can tell. So given this box plot, can I tell the median and my measures of spread and then give an interpretation of the data? So the median and the measures of spread are just the ones that we just went through. The lower extreme, my Q1, my median, my Q3, my upper extreme, the IQR, and the range. So what is my lower extreme? 1. What's my Q1? Does everybody not see where he's getting these numbers? Because I don't want Owen answering all of them. Jolene? Lower extreme, first dot. It's at 1. Q1, this dot. It's halfway between the 5 and the 6. So now where's the median going to be? Nope, let Jolene answer. Is it right above the 8? It's right above the 8.5? Yeah. It's not hard. It really wasn't a trick question. It literally is that easy. That's what makes box and whisker plots nice. They're very easy once you understand what they're representing. They're very easy to read. So my Q3 is, what do you think, Jake? Do what? 11. No, just 11. It's right above it. Go right above the 11. It's right there. What's my upper extreme, Eli? So my IQR is what? Cannon? How'd you get 2? How do I find the interquartile range? How do I find the IQR? Alex, you think you got it? No? Math error, 5.5. 11 minus 5.5, 5.5. Again, that's Q3 minus Q1. What's my overall range? How'd you get that, Christian? 13 minus 1. So the one thing we haven't done yet is interpret. You can tell me something that you learned by looking at this graph about the American Football Conference wins. Owen? Awesome. Perfect. And I would even add, no team went winless. We didn't have any Detroit Lions that year. No team won all their games. We didn't have any Miami Dolphins. 72-6 Dolphins, the only team to win all 16. They're actually the only team to go undefeated all year. They won the Super Bowl as well. So there's a lot of different things I can tell from this. But any of those would be an interpretation as long as it's valid. Okay, let's do this next one. Do you guys want to do it together or do you want to do it by yourselves? Do you want another practice? Raise your hand if you want to do it by yourself. Raise your hand if you want to do it together. Looks like the soloists win. Now, I do want to just clarify because I had trouble reading this. We're going to call that a 7 and that a 7. Okay? You've had some practice. I'll give you 5 minutes to do this one. It's a much smaller data set. Okay, so let's go through this one very quickly. Again, organizing it in order. We've got a 1. We've got a 2. I've got a 3. I've got a 4. I've got 3 5s. I've got 2 7s. 1 2 9s. 10. An 11. And a 15. Okay, always double check, guys. Remember, once I reorganize my data, it is critical that I count my data points. So I have 2, 4, 6, 7, 14. 2, 4, 6, 8, 10, 12, 14. Check. So the nice thing is, that does 2 things for me. Number 1, I make sure I copied my data right. Number 2, I now know how to find my median. So if there's 14 data points, where's my middle? The 7th and 8th data points. So I count 2, 4, 6, here's 7 and 8. So I need to average the 2 of those together to find my median. So the median is 6. So that now gives me my break point to find my lower and upper upper and lower medians, so that I can now find my Q1 and Q3 values. So if I had 7 now on each side, that means my median is going to be where? What's my dividing point if I have 7 numbers? The fourth one. No, it's an odd data set. That means there's going to be 1 in the middle. So I look to the fourth one, 2, 4. It's the 4 here. That's my Q1. I do the same thing here, 2, 4. That's a 9. That's my Q3. Yeah. I split them all evenly. That's the idea of a median. Median is the middle number. Okay? Now to draw it, I've now gotten all my numbers I need, right? The one thing I didn't check yet was for my outliers, right? So Q1 is 4, Q3 is 9. That means I have an IQR of my interquartile range. 9 minus 4. 9 minus 4, Amiri. So an IQR of 5. So half of 5 is 2.5. So I'm looking for a value of 7.5. If I subtract 4 from 7.5, I'm in negatives. I don't have any negative numbers, so I'm good there. I add 7.5 to 9 is 16.5. So all of my numbers are within my data set. I have no outliers. So now I'm just going straight off with what I've got. So now my 1 is my LE, my lower extreme. 15 is my upper extreme. I plot all those dots. There's the 1. There's the 4. There's the 6. There's the 9. And there's the 15. Draw my 3 straight lines. Connect those with the box. And my whiskers go to the middles. Do what? Good name for a cat. For those of you at home didn't hear, Amiri's cat is named Whiskers. So our box and whisker plot now has even more meaning for him. Guys, key question. What percent of the earthquakes are between 4 and 9 kilometers deep? What do you think, Alex? Oh, so close. You just said it wrong. What is it, Mackenzie? 50. How did you get 50%? Good. Because that's my Q1 and Q3 values. I know that half of my data lies inside that box. 50%. Okay, let's go to that next page. Don't worry, Connor. It won't last long. Okay, here's where, guys, focus back in. They've already given us now our box and whisker plot, or our box plot. Now I'm just going to ask you to interpret it. So this should go relatively quickly. Where's my median? 27. Median, remember, median is that middle value. 27. Where's my upper extreme? 40. It's halfway between the 39 and 41. Where's my lower extreme? 22. My first quartile. 25. My third quartile. Giving me an interquartile range of what? 8. Again, interquartile range, Q3 minus Q1. Starting to get them? Good, now that you got that, let me throw a curve on you. Okay, guys, here's where box plots become important. And this is why, like at the DSO, the district office, they love box plots. Why? Because they compare entire grade levels, entire schools, where I have hundreds or thousands of pieces of data. A box plot gives me a very good visual reference to make comparisons, showing me where the majority of the data lies. Cannon? There's an open one out there. They're using the one open door so to show them how big the lockers are. So at home, just so you know, 5th grade is now touring our school to see what it looks like for next year. Guys, quiet back down. Quiet. Thank you. So in a double box plot, all they're doing is putting two box plots on the same line. So they're going to have the same number line, but what it does, it allows you to get a good visual representation for what the differences are between the two data sets. It's more than just that, Bob. Guys, Alex? Guys, quiet down, please. Izzy, stop. Uh-huh. So this would be like our 7th graders. This is our 6th graders, talking specifically about our homerooms and how big they are. Okay? So if I plotted out the data, if I took all the homerooms in the school and said how many students are in each one, then this is what it would look like. Okay? So compare the median number of students in homeroom for each grade. So what is my median number for 7th grade? 7th is 24. What about for 6th? 19. So the median is higher for 6th grade, or for 7th grade. Okay? What about the range of the students for each grade? What's the range for 7th grade? I'm sorry? 31. 14, because I go from 29 to 15. So 7th is 14. What is it for 6th grade? It's what? It's also 14, 26 to 12. So the range is the same. Now, compare the middle 50% of homerooms. So how do I find the middle 50%? The box portion, right? So the middle 50 is that box portion. So for 7th grade, it goes from 22 to 26. For 6th grade, what is it? What's the middle 50% for 6th grade? 18 to 24. So if I were to compare those, what would I say? There's more variability in 6th grade. So in other words, the range there is larger. Okay? So interpret the double box plot. Now again, anytime we're talking about interpreting, anything I could pull out of the numbers is a valid interpretation. So there's a lot of different things I could say, but when I look at this, the big one I say is 7th grade has bigger homerooms in all, basically every aspect. Yes. I will allow them to earn bad grades. Okay, guys, go ahead and turn to the next page. Here's your homework. Really quickly. Guys, listen. The top two, you need to do a box plot. All the rest is just interpretation.